Einstein received a Nobel Prize, but he did not receive it for his work on special relativity and general relativity, for which he's the most famous. He received it for an effect called the photoelectric effect. And what this effect is a demonstration that light comes in packets. And so what I have here is a piece of zinc and a source of ultraviolet light. And I'm going to irradiate this zinc with this light, and the photons of ultraviolet light will penetrate this surface and kick electrons off of the surface. To show you that electrons are being kicked off the surface, we're first going to charge the surface negative using this ebonite rod and fur, and you'll be able to see the Braun electroscope needle move, indicating that the surface is charged negative. Then we'll irradiate it with this ultraviolet light, and you'll see the needle come back to zero again. Okay, let the needle stabilize just a little bit. Give it a little bit more charge. And then we're going to irradiate the surface with this ultraviolet light. So what you have to imagine was happening over these few seconds was that ultraviolet photons were hitting the surface. And when one ultraviolet photon hits the surface, as long as its energy exceeds the work function of the surface, that single photon will kick a single electron off the surface. And then as enough photons hit the surface, then enough electrons leave the surface and leave the surface neutral again. That's the photoelectric effect. Very important in technology. Photoelectric sensors are in the earth, sensing light produced by neutrinos from the sun in order to understand the structure of our sun and its history, the future of the earth. The photoelectric effect is used all the time in photography and other disciplines to capture light and indicate that you've had light hit a surface. That's photoelectric effect.